just a picture or in a model or um, with the help of those graphs, charts, and other visualization tools. Okay, so let us start. Okay, so correlation analysis. So correlation analysis is used to assess how well a model can predict an outcome. So in case of mga researches, um, how how the independent variables, the independent variable or independent variables can predict the outcome of the dependent variable. Okay, so correlation analysis involves several statistical calculations. So all done with a computer. So you can use a computer. I think sa Microsoft Excel. So pwede na siya. Or using of your scientific or financial calculator using the observed values of X and Y. So usually ang ibutang nato sa values sa X are those independent variables. While in the Y, so this is our dependent variable or also known as the outcome variable. So correlation analysis is used to determine how well correlated the variables are in order to decide whether the independent variable or variables can be used to make decisions regarding the dependent variable used in the analysis. Okay, so examples sa economics, so we have price and quantity demand. So price is our independent variable and quantity demand is our Y. Okay, so based on the studies in the past, so price is one of the variables that could really affect the quantity demand. So as they have observed, so if the price is high, so the quantity demand for a product or service is low, and if the price is low, the quantity demanded is high. Okay? So they are negatively correlated. So opposite ang ilang direction. If the correlation is positive, okay, so in the case of the law of supply, so if we increase the price, the quantity supply will also increase. If you decrease the price, then the quantity supply will also decrease. So it's called the positively correlated or directly proportional. So these are some of the most important statistical calculations for determining the correlation. So we have the correlation coefficient, so denoted by letter R, standard error of the estimate, or also known as the standard error of the regression. Okay, so usually it's denoted by S or E. So no, the third one is the coefficient of determination. So actually, kuha din siya, R, uh, how do you call this? Kumbaga, this is R squared. Okay? So dili na siya 2. So na na siya exponent. And then last is the T-Statistics. So we will discuss each of them unsay relevance ani nga mga statistical calculation. Okay, next. So what is a correlation coefficient? So the correlation coefficient measures the relationship between the independent variable and the dependent variable. So you're trying to observe the values of the independent variable against the values of the dependent variable. So the coefficient of correlation is a number that that expresses how closely related the two variables are and the extent to which a variation or the difference in one variable has historically resulted in a variation in the other variable. So in the correlation coefficient, so you have to get data. So um, usually mga historical data. So imo dayon na siyang i compare. So are they um, so if ang isa ba ka variable kung mag-increase ba ang isa or mag-decrease or they don't have any relationship at all. So walay direction ang isa. So mathematically, the correlation coefficient is represented by letter R. So it is a numerical measure that expresses both the direction. So if the resulting is positive, so it's directly proportional, or it could be a negative correlation coefficient. So it denotes opposite direction or inversely proportional. And also it also measures the strength of the linear association between the two variables. So how closely related they are. Okay, so the resulting correlation coefficient is expressed as a number between the negative 1 and positive 1. Okay, so negative 1, ang resulting ng mga correlation coefficient is either between negative 1 and positive 1. So, unsay purpose sa mga sign? So, the sign of the correlation coefficient and the absolute value, the sign denotes or describes the direction, while the value, okay, the numerical value, um, it describes the magnitude or how closely related the two variables are. So if the correlation is positive 1, so kung maabot gani sa positive 1, it means that the relationship between x and y is perfectly positive. So meaning walay error or walay changes sa actual o sa estimate. So they are in the points, the historical data points are in the same line with the regression line. So it is also known as the upsloping. So pag positive, so pataas. If the correlation coefficient is negative 1, it means that the linear relationship between the two variables x and y is perfectly negative. So pwede sa niya negative 1. So pag moabot siya negative 1, um, it is called perfectly negative. Okay, so in the case of price and quantity demand, so it is negative downsloping. So magkaduol sa 1 ang value, so magkataas ang relationship or magka-close ang variables or the two variables from one another. If magkalayo sa 1, so it could lessen the relationship sa duha ka variables. So a correlation coefficient that is close to 0, so pag ang result is close to 0, it means there is a very little or perhaps kung 0, no relationship between the values of x and values of y. So you cannot use the values of x to predict the values of y because they don't have a relationship. Okay? So of course, the higher the correlation or the nearer to 1, whether it's positive or negative, so the higher nga pwede ka mag-rely sa sa values of x to determine the values of y. So the the dependent variable. Kung magkaduol sa zero, then you cannot use the values of x to determine the outcome of the values of y because they are not correlated. Okay, so that's the meaning of the results of the correlation coefficient. So again, a high correlation, that is a number close to either positive or negative one. So the linear regression analysis is useful in making a projection. So kung magkaduol siya sa 1, either positive or negative, then the linear regression is useful in forecasting or projecting the values of the dependent variable. So generally, a resulting correlation coefficient of plus negative 0.50, so at least 0.50 or higher. Okay? So if the resulting correlation coefficient is 0.50 or higher, it indicates enough correlation that a linear regression can be useful for forecasting. So pwede daw nimo gamiton ang values ni x to forecast the values of y if the correlation coefficient is at least half or 0.50, whether it's positive or negative. Otherwise, dili nimo pwede gamiton ang values ni x to determine the outcome of y. So for example, sa price o quantity demand, so if the correlation coefficient is 0.50 or higher, okay, so you can use the price to determine the quantity demand. Pero if, let's say, the two variables are, the correlation coefficient is 0.41, okay? So for example, climate, and then the quantity demand for food, okay? So climate. So whether it's a hot or cold season or rainy season, so i-correlate mo sa um, food or sa quantity demand for food, and then the resulting coefficient is less than 0.50. So it means that you cannot use the climate as a determinant whether mo increase ba or mo decrease ang quantity demand for food. Okay? So if R is positive number close to 1, say 0.83, it indicates that the data points follow a linear pattern fairly closely and the pattern is upsloping. So it means that the historical data is kumbaga duol kaayo siya sa regression line. Okay? So they are not far from the regression line. Okay, so let's continue. If R is a negative number close to negative 1, so let's say as negative 0.77. So it's a downward slope. So it indicates that the time series that the data points, it follows a linear pattern. So murag line gihapon siya og porma. However, the direction is opposite. So let's say katong sa price o quantity demand. So it is observed that as we increase the price over time, so our quantity sales or quantity demand will decrease. Okay? So pag negative, it indicates that the direction of the variables are opposite. Ang isa nag-increase, ang isa nag-decrease, or perhaps ang isa nag-decrease, ang isa nag-increase. So mo na indication sa mo na pasabot sa mga negative nga correlation coefficient. So kung magkaduol, let's say mas duol siya sa 1, so 0.77. So kung imo na siyang i-plot ang data points in a graph, so it is very near to the regression line. Okay? So halos mutunong siya sa regression line. So it is said that you have a moderate correlation coefficient, so generally defined as plus minus 0.30 to plus minus 0.49. So kung less than 0.50, okay, so naa siya between 0.30 to 0.49, whether positive or negative. So it is a moderate correlation coefficient. So pangutana ana if pwede ba na nimo gamiton to forecast or to predict. Okay? So if the correlation coefficient is between 0.30 to 0.49, so it has a lower amount of correlation. And you will have a questionable value of the historical data for forecasting. So medyo doubtful ka whether sakto ba imong estimate in the future because the correlation coefficient is lower than 0.50. So questionable siya or to use the historical data for forecasting. If the correlation coefficient is around mga plus negative 0.10, so kung 0.10 below, 0.10 and below, it indicates that the forecast made from the data using simple regression is not useful. So dili na siya pwede nimo gamiton um, for forecasting purposes. Okay? So dili na siya pwede. So the correlation coefficient does not indicate how much. So mo lang ni ang disadvantage sa correlation coefficient. It does not indicate how much or the variation in the dependent variable that is explained by changes in the independent variable. Because daan magay mga variables na posibleng wala nato na capture in studying the outcome of the dependent variable. Let's say, let's go back to the quantity demand, 'di ba? Sa isa ka product. So, we are only studying the price as our independent variable and then atong study unsa iyang impact sa dependent variable. However, there are variables nga wala nato na capture because as we know, customers dili lang na gabase sa price whether to buy something or not. Okay? Sometimes they look at the quality of the items or service, or perhaps there is a sentimental value of that property. So sa mga especially mga arts and mga antiques. Okay? So kumbaga daghay variables why a certain quantity demand is uh, will result sa inana. So mo na ang weakness ni correlation coefficient, it does not indicate how much. So how much can we rely on the results of the correlation coefficient? So ang naara nga data sa correlation coefficient is to know whether there is an upward or direct relation or inverse relation between the independent variables and the dependent variables and also the strength of the relationship. So kung duol ba siya sa 1 or layo ba siya sa 1. If duol siya sa 1, then most of the time correct na siya nga result. So let's say 0.87. So it means 87th of the time, okay, 87th of the time inana permente ang may tabo. Nga si price, pag mo increase og price, 87% may tabo nga mugamay atong quantity demand. But there are other percent, 13% nga wa ta kasayod nga even though nagtaas ta og price, ni-increase gyapon ang quantity demand. Okay? So because of this weakness, that's why we also need to look at the other statistical tool. So we have to look at the coefficient of determination, the T-statistics, and standard error of estimate. Okay, so what is the use of the standard error of estimate? So the standard error of the estimate represents the average distance that the observed values fall from the regression line. So if you're, kung na-remember to ninyo akong gipakita nga graphs last time. So, di ba, when we draw a regression line, there are points nga wala sa linya. Okay? So, we call that variation or the distance of the actual result to the estimated or the forecasted result. Okay? So, if layo ang mga data points sa regression line, then there is a high standard error of estimate. If dool kayo ang mga data points sa regression line or kung mo fit sa regression line, it is said nga walay error ang ato ang forecasting. Nga most of the time, kung unsa atong gi-forecast, mo gyud na ang mahitabo sa actual. Okay? So, in other words, the standard error of estimate describes how wrong the regression model is on average. Okay? So, how wrong? So it means nga what could be the possible error or mistake sa atong forecast. Okay? So we need to average the usual error from the actual results to the forecasted results. So standard error of estimate is denoted by E equal to Y, or this is the dependent variable but actual ni siya nga value sa dependent variable. Y minus the Y hat or the forecasted Y. So this is our prediction. So unsay difference kasagaran sa actual o sa forecasted? Unsa kasagaran ng atong error, okay? On average. So if you recall, in getting the forecasted y, okay, katong y hat, so di ba, the formula is a plus bx. So a is the constant coefficient or the y-intercept plus b or the variable coefficient, x is the independent variable. Okay? So sa forecasted, mo na ang formula. But to get the actual y, okay, to get the actual y, or the actual results of the dependent variable, i-add na to sa formula ang error estimate or the standard error of estimate. Okay? So also known as the residual. So for each value of x, so the difference between the estimated y and the actual value of y. So mo na kasagaran niya error sa atong forecast. So every time mo forecast og y, ni kasagaran ang difference nato sa tinuod or sa actual nga dependent variable. So of course, you can only compare the y hat and the actual y after na mahitabo. Let's say you are forecasting the income for 2021 or 2022. Okay? So pwede na ka maka-forecast og income for y hat or so depende na sa imong mga historical data. But to compare a y hat and the actual y, so you have to wait for the financial statements nga mahuman at the end of 2022. So diha pa nimo makuha ang actual y. So of course, kung magkagamay ang error estimate or residual, so magkataas ang atong reliance sa ato ang forecast. So again, kung magkagamay ang error, we will taas atong reliance on our forecasted Y. However, if the error estimate is very high, then most likely, sayo permente ato ang forecast. Okay, yung ato prediction. Okay, so take note that smaller values for the standard error of estimate are better. So we want nga ang atong standard error of estimate are small. So that the observations are closer to the fitted line or the regression line. So kung gamay ang error, then mas taas atong reliance on our forecasted value kaysa sa katong taas og standard error. However, the size of the standard error must be interpreted in relation to the average size of the dependent variable. So if the usual size of the dependent variable is 5 million and the usual error is 250,000, so it's only 5% of the standard of the actual values in the dependent variable. So it is fairly small. Okay? Although ang amount na 250,000 is already high, but in relation to 5 million, it is a small percentage. So it is said that if the standard error of estimate is between 5 to 10%, so kung ang makuha daw nga standard error is 5 to 10% of the dependent variable, so we can still use the regression line as our forecasting tool. Okay, so it is said that the regression analysis is fairly precise. Okay, so you only have an error of possibly 5 to 10%. So it means that if your standard error if is 5%, it means that 95% of the time your regression analysis is correct. If the standard error is 10%, so it means that the regression is 90% correct. Okay, 90% correct. 90%. Your regression analysis is correct 90% of the time. So, so why do we need to include the error? Okay, so mo ni ang mga rason nga nung we have to take note of the standard error of estimate. First, so it is to recognize that our regression model is imperfect. Okay? So, ang atong regression model may not be able to accurately forecast. Okay? Second reason why there's an error term, there might be some variables that help to explain the behavior of the dependent variable that wala na to gi-include. As I said yaina, the dependent variable nga quantity demand, dili lang na siya tungod sa price nga factor. But there are also other factors why certain customer would buy our product. Okay? So probably na variable nga quality of the product or perhaps sentimental value and so on. Okay? So the variables that we have might not fully explain the behavior of the dependent variable because natay variable nga wala na nakita. Okay? And then wa siya na-appeal sa ato ang study. And then last one, the included variables may have been measured with error. So posible nga na ay error sa pag-include nato sa um, error sa atong variables. So there is always some component in the variation of the dependent variable that is completely random. So na mga changes in our dependent variable nga posible dili na siya all the time may tabo. Okay? So let us say increase kag price, so you are forecasting nga mo decrease imong sales. But there is an event nga wala na to na capture. Like for example, the COVID-19 situation. Okay, so the reason probably nga nung gamay kag quantity demand is not dili lang tungod na sa price, but perhaps due to the economic situation in the country during the pandemic. And not all the time nga naatay pandemic. So it just happened nga ni coincide lang siya sa imong pag-decrease sa price, sa pag-increase sa price. Munang nisabot siya kaubos ang imong sales or quantity demand. Okay, so let's go to this another statistical tool, which is called the coefficient of determination. So to get the coefficient of determination, you simply uh, is pangitaon lang nimo ang square of the correlation coefficient, okay, which is denoted by letter R. So imo nang i-square ang correlation coefficient, and that's your coefficient of determination. So sa pasabot sa what's the use of the COD or the coefficient of determination? Okay, so it means that the percentage of the total variation in the dependent variable can be explained by the variations in the independent variable. Okay, so meaning whatever is the resulting coefficient of determination, pwede ka makarely sa imuang correlation coefficient. So let's say the correlation coefficient is 90%. Okay, so meaning that variable um, can explain the variation in y. So the cost of the dependent variable is caused by letter x, but only for 90%. So let's say price and quantity demand. Okay, so the resulting coefficient of determination is 90%. So meaning uh, the resulting quantity demand is caused by the price, but only for the 90%. So 90% lang ang impact ni price sa quantity demand. But the rest of the variables, the 10%, so the rest of the 10%, mo na siya maka-explain, o the rest of the variables katong 10%, mo na maka-explain sa 10% impact sa quantity demand. So, okay, so I will explain that later. So in a simple linear regression with only one independent variable, so the coefficient is the square of the correlation coefficient. So the coefficient of determination is expressed as a number between 0 and 1. So naragyan na siya in between 0 and 1. So if your coefficient of determination is 1, then 100% of the variation in the dependent variable is caused by the independent variable. So ang impact the independent variable, uh, the resulting y is caused 100% by the independent variable. So wala na ilaing variables nga naka-apekto sa dependent variable. If the resulting coefficient of determination is 0, it means that none of the variation in the dependent variable can be explained by the independent variable. So in short, sa kaning independent variable nga imong gistudyhan, wala siya dili siya maka-impact, okay? Or wala dili siya maka-explain sa dependent variable. So nganong inana ang quantity sa dependent variable? If the COD is 0, then the independent variable cannot be used to forecast the dependent variable. So in a regression analysis, the high coefficient of determination, so magkataas ang COD, pag imo na siyang i-graph, so the actual data points is very close to the regression line. So almost nga naa na gyud siya within the or in the regression line. In a regression analysis with a low coefficient of determination, so may bawa na nimo because the data points are very scattered. Okay? So daghay naa sa taas sa line, sa ubos. Okay? So the higher the R2, the better the predictive ability of the linear regression. So we want a coefficient of determination nga very close to 1 because it means that um, the predictive ability of the high or the regression analysis is very high. Okay, so another statistical tool is the T-Statistic or the T-value. So it measures the degree to which the independent variable has a valid long-term relationship with the dependent variable. So yeah, the T-Statistics measures kung unsa ka ka strong or ka legit ang independent variable in explaining the dependent variable. Kung sa siya ka-credible. So the t-value for the independent variable used in the simple regression should generally be greater than 2. Okay, so take note, greater than 2. So it means that the independent variable can generally explain the dependent variable. So a t-statistic that is below 2 indicates no relationship or a little relationship between the independent and dependent variable. So sa pag-interpret niyo later and then you found out that the t-statistics is 2 and above. So confident mo ana that the independent variable can predict the dependent variable. However, if the t-statistics is less than that, less than 2, then namoy doubt whether the regression analysis between the independent and dependent is related. So it means kung dili sila related, then you cannot use the independent to forecast the dependent variable. So those are the common statistical tools for the simple linear regression. So when you say simple linear regression, there's only one independent variable and one dependent variable. Okay. So however, there are studies or researches nga usually dili lang isa ka independent variable ilang gina-test. So there are a lot of variables and then lots of dependent variables. So if more than one na gani ang independent or more than one na sad ang dependent, then we cannot use the linear regression nga analysis. Okay? So that calls for a multiple regression analysis. Okay, so if there's more than one independent variable that impacts the dependent variable, and each of them can be expressed numerically, so regression analysis using the independent variables to forecast is called multiple regression. Okay, so however, you have to take note that it doesn't mean nga they are correlated. Pwede na kamo ingon nga there is a cause and effect between the two variables. Okay? So correlation does not prove causation. So that's why in your RL, so you need to find evidence whether the two variables are connected to one another. because correlation alone is not enough. Okay? So, unsay formula sa multiple regression? So, kung pila na siya ka independent variable, inana pud kadaghan ang A1 ang AX. Okay? Okay? However, the multiple regression analysis is a very advanced na siya nga statistics. So, focus ta sa katong linear regression. Okay? The one with the one independent variable and one dependent variable. So, goodness of fit in regression analysis. So, the term goodness of fit describes how close the actual values to the predicted values. So, if the actual data points ba, mutunong ba siya sa regression line? So again, if the distance between the actual data points and the regression line um, is very close, then we can say that there is a goodness of fit. So in regression analysis, the regression equation is the model used to predict the future values. So based on the behavior of the actual observations. Okay, so thus the correlation analysis described in this topic leads to the measurement of the regression equation's goodness of fit. So kung unsa siya ka-close sa regression line. So take note, for example, this is a variable that is very close to the regression line. So kani mga dotted lines or broken lines, this is the regression line. And then the green ones are the actual data points. So in this case, sales. So mga actual sales ni siya. So as you can see, so there's a very so the actual data points almost fit the regression line. Namang gani data points nga wala sa line but still they are very very close. Okay, so we can say that this data has a goodness of fit. If the independent variable or variable used in the regression are not well correlated, okay, so the regression line that we have computed or come up is said to have a low goodness of fit. So mo ni atong regression line, but notice that the data points or the actual results are very far from the regression line. So it means there is low goodness of fit. It's also indication that there is no relationship sa independent variable o sa dependent variable. Okay, so confidence interval. So usually ang confidence interval is the calculated by deducting 100% sa iyang standard error of estimate. So in business, so we tolerate a 5% error. So that means that the confidence interval is 95%. But there are studies nga they only tolerate nga mga 2%. Okay? So unsa pasabot ana, so the confidence interval for those researches is naas na 98%. So pasabot sa confidence interval is that uh, since you only have a 5% error, it means that 95% of the time you are correct. Okay? 90% of the time you are correct. If the standard error is 2%, so you have a confidence interval of 98%. So that's gigon sa pagkuha, 100% minus the standard error or the tolerable error. So if you have an error, a tolerable error of 2%, then the result of your study has a confidence interval of 98%. So which means 98% of the time you are correct, or it really reflects the population. Okay. Okay. So before we continue, so let me know if you have questions or clarifications before we proceed. Are there any questions, clarifications? Okay, so before we proceed, I'll give you 2 minutes. Okay, 2 minute break. So after 2 minutes, we will continue with the discussion of visualization. Okay, thank you. Okay, so let's go back. So let's have a sample na results of mga correlation. So here's a sample problem. So according to advertising age, annual salary. So Mark Hurd, the 49-year-old chairman, president, and CEO of Hewlett-Packard Company, received an annual salary of 817,000, a bonus of more than 5 million, and compensation exceeding $17 million. His total compensation was slightly better than the average CEO total pay of $12.4 million. So we have a table here showing the age and annual salary of the executives who lead publicly held companies. So these are the names of the executives, their title, the company they are connected, the age, and then the salary. So in this problem, so we're trying to compute first the correlation between age and the salary of these executives. Okay, so for question number one, for example, so based on the information given in the problem, so which of the two variables of interest is the independent and dependent variable? Okay, so in this case, our independent variable is the age of the executives, while the dependent variable are the salaries. Okay, so their annual salaries. So second requirement, develop a scatter diagram for the two variables and labor which is the predictor variable and which is the response variable. So we say predictor variable, it refers to the independent variable, while the response variable is the dependent variable. So if we try to make a scatter diagram out of this data from this table, so age and salary, so this is the resulting scatter diagram. So even without a regression line, as you can see, um, the movement is upward sloping. Okay, so the data points are upward sloping. So it means that the relationship between the age and the salary are positively uh, or directly proportional. Okay, so they are directly related. So as the age of the executives, uh, as they become older, rather, their salaries also increased. So the predictor variable here is the age, while the salary is our response variable. So number three, what does the scatter diagram developed in part two indicate about the relationship between the two variables? So as we can see in the scatter diagram, so it indicates that the two variables are positively or directly uh, related. So it means that as the CEO gets older, his or her annual salary also increases. So question number four. So although we can already see that they are directly related, but we have to verify it first with our correlation coefficient. So verify the answer in number three by calculating the correlation coefficient and interpret the results. So for example, you have already calculated the correlation coefficient and you found out that the correlation coefficient is positive 0.95. So it's very, very near to positive 1. So if the correlation coefficient is positive 0.95, it means that it has a very strong positive relationship. So number 5, using the least squares method. So calculate the regression coefficients and formulate a model that will define the relationship between the two variables. So using the regression equation, so to get the response variable or the y hat, so this is our formula. So our fixed coefficient or the constant coefficient, no, this is the variable coefficient. So that's a 149.2888x. X represents the age of the executive. So 149 multiplied by age plus 6,745.44. So that's our constant coefficient. So plus atong ibutang, it's because they are positively correlated. If negative pa ang coefficient, then our slope or the equation would have a negative nga component. So interpret the coefficients, the slope, and intercept of your model. So the model predicts or estimates the annual salary given with age. So for example, if the age of the CEO is 50, okay, so by the way, kaning nasa table, so kaning salaries diri are wala pa na siya, in thousands na siya. So does it mean nga yung annual salary is only 1,000. But ang 1,000 i-multiply pa na sa 1,000. So it means that kaning nga figure, ang meaning ani is 1 million. So compute the salary of the CEO if the age is 50. So get the result. So 149.28 plus 50 at multiplied by 50 plus nani. So the resulting figure is 719,000. So 7, calculate the coefficient of determination and interpret. So based on the calculation, it has a coefficient of determination nga 0.9039 or 90.4%. So pasabot ana that 90% of the outcome or the y is caused by the independent variable nga age. Okay? So 90% lang. The rest sa 100%, so more, it can be explained by other variables, other independent variables. Okay, so suppose Bill Gustin, a 72-year-old chairman, president and CEO of major electronics company. So predict the annual salary of Bill Gustin. So using our formula, so 149.28 multiplied by 72 plus 6745. So you will have 4,353.60. So suppose you are a CEO of a big company 10 years from now, predict your annual salary. So for example, 25 years old, if you are 25 years old, so 10 years from now you will be 35. So take note that our scatter diagram started only age. I think the youngest here is 49. So ang 35 nga age is not within the relevant range. So mo po na yung isa sa kuan sa correlation. So kung unsa toy data, minimum and maximum data, kung wala dira imong age, so you're out of the range. Okay, so the model cannot explain or cannot predict your annual salary because you are not within the bracket, okay, sa age. So ang model nato is only good if your age is between 49 and I think the oldest is 82. So di ara taman ang usefulness sa model. Beyond that, so minimum ana og outside ana nga scope. So we call that the outside of the relevant range. So you cannot predict your annual salary. However, if your age is within the relevant range, so pwede nimo gamiton ang model. Okay? Itong sa linear regression or the least squares. Okay, so that's how we use how do we interpret the correlation coefficient ng mga statistics. Okay, so now let's go to visualization. So especially in thesis, so it's very important to use sa mga visual tools. So using of charts, tables, dashboards can be used to explore, examine, and present or display your data. The interactive dashboards allow users to access and interact with the real-time data and give managers a means to quickly see what might otherwise not be readily apparent. So the most common visual tools is the table. So a table can be in any form and include all of the data available or only certain data. So for the rest of the visual tools, so mo ni atong data nga gamiton. So the table contains data on the number of pounds of strawberries sold on each day of the week by a grocery store over a 12-week period from June 3 to August 25. So this information is used in placing orders so that enough strawberries are purchased to meet the anticipated demand each day without overbuying and having excess strawberries that will need to be thrown away because they spoil. So that's why it's very important to forecast quantity demand so that dili kayo dili na kayo madaot, especially sa mga agricultural products. So in addition to daily strawberry sales for each days of the week for 12 weeks, the data table below contains the mean, or also known as the average, for each day of the week over the 12-week period. Okay, so from June 3 to 9, that's first week, and so on until August 19 to 25. So these are the strawberry sales for each week. So Monday, every Monday, Tuesday, so on until Sunday. So the mean or the average per on Monday is 25, and then sales on Tuesday is usually 40, 60, and then on Sunday until Sunday, gamay na lang. So 20 na lang ang sales. So this is the use of the table. Another visual tool is called the scatter plot. So the scatter plot can be used to show all the values for a data set, typically when there are two variables. So one variable may be independent and the other one may be dependent. the other value or the dependent variable or both variables may be independent. So it is generally plotted on the horizontal axis and dependent variable is plotted on the vertical axis. So sa scatter plot pa lang daan, makaibaw na ka whether it has a chance of being correlated or not. So for example, do sales of strawberries correlate with days of the week? So a scatter plot can answer the question. So this is an example of a scatter plot. So same data gyapon ni siya. So the color, the different colors, na siya gi-represent niya week. So these are for 12 weeks. So gi-plot niya tanan. So as you can see, there is some pattern. So it is increasing until Saturday. Then pag abot og Sunday mo decrease ang sales. So mo decrease ang demand on Sunday. So it almost forms a line or a pattern. So it has a high chance of being correlated. So charts contain the summarized statistics. So we have discussed gaina what are the different statistics. So it could be the means, the maximum values, and minimum values. So first chart that can be used is called the dot plot. So the dot plot provides information in the form of dots. So a dot plot can be used to visualize several data points for each category on the x-axis. So for example, the following dot plot shows the minimum, so the minimum quantity sold on that week, the maximum sales, and the mean or the average um, sales for each day of the week during the 12-week period. So makita ni dira is the minimum sales which is denoted by the light blue nga dot, maximum is the red, and then the mean or the average is the green. Okay, so that is dot plot. Okay, so another visual tool is the use of the bar chart. So a bar chart is useful for comparing statistic across groups. So the height of the bar or the length of it, if the bar chart is displayed horizontally, displays the value of the statistic. So ang bar chart can either be horizontal bar chart or a vertical bar chart. So this is an example of a vertical bar chart. So usually ang ginakuha niya is the mean or the average strawberry sales per day. Okay, so as same with the scatter graph and the dot plot. So there's an increasing trend from Monday to Saturday. Sunday is the day nga gamay sila og sales. So this is the chart for the horizontal bar. So pwede pa vertical, pwede pa horizontal. So with the use of bar, same gihapon, blue is the minimum, green is the mean or average, and red is the maximum sales ana nga day. So same gihapon, Saturday ang pinakataas, and then Sunday ang pinakaubos. So vertical bar, this time with the maximum, mean, and minimum. So another tool that we can use is the pie chart. So it is in the form of a circle that portrays one value for each category. So marked as pieces of a pie. So in the example that follows of the mean pounds of strawberries sold per day, so the size of the pieces helps the user to visualize the relative size of the sales for each day. However, the limitation of the pie chart is that it can only present one value for each category. Okay, so usually we cannot present the mean, average, and the maximum if magamit ta og pie chart. So usually ang ginagamit sa pie chart are only the mean, okay, or the average sales per day during the 12 days week. I mean during the 12 week. So on Sunday the average sales is 20 pounds, Monday 25, then the biggest share sa pie is sa Saturday, so which is 90 pounds per day. So in the pie chart you will know kung asa ang pinakagamay og share and pinakadako og share. Another tool is the line chart. So a line chart can be used to visualize several observations for each category, using one line for each observation. So the strawberry sales data are shown on the following chart as the minimum, the maximum, and the mean values each day. So same color, red is for maximum, blue is minimum, and green is for mean. So as you can see sa tulo ka line, they almost have the same pattern. Okay, so another is the bubble chart. So the bubble chart replaces data points with bubbles that vary in size according to the size of the bulbs they depict. So magkagamay ang bubble, magkagamay ang value, magkadako ang bubble, magkadako ang amount or quantity, magkadako ang size sa bubble. So in this case, ang pinakagamay nga bubble is on Sunday. So 20, then pinakadako nga bubble is on Saturday. So 90 pounds per day. So in just one look, kay balo na ka kung asa ang pinakataas og sales ug asa ang pinaka-ubos og sales. Okay, so there's no recommendation as to asa ani inyong gamiton to present. The only criteria here is to present or to look for a visual tool that you think uh, can really convey the information that you want to present um, to your client or to whoever is you are presenting to. Okay, so whether it's for thesis or what. Okay, okay, so there are also charts containing the entire distribution of values. So the first one is called the histogram. So the histogram is actually have the similar features with the bar chart. However, in this case, so dili lang isa ka value ang naa. So but the frequencies, okay? So frequent or how many times that you sell the strawberries. So if there's 1 to 20 pounds, so how many days in the 12 weeks nga permente ka na ay sales nga 1 to 20 pounds and others. So the values of the variable may occur over a period of time or they may be as a moment in time. So for 1 to 20 pounds, so you have 12 21 to 40, 20, 18, 14, 12, and lastly is 101 to 120, which is 8. So to convert that into histogram, so mo ni ang itsura. So, 'di ba? It's almost similar to a bar chart. However, ang makita nimo sa ubos are the frequencies. So, 1 to 20, 21 to 40, 41 to 40, and so on. So, the histogram is also one of the common visual tools nga ginagamit sa mga thesis or mga research. So, last is the box plot. So, a box plot is another type of chart that is used to display the full distribution of a variable. So a box plot also shows the minimum, the first quartile, the median, the mean, the third quartile, and the maximum sales for each day of the week, as well as individual observation for each day of the week. Okay, so muna ang itsura sa box plot. Okay, so table sa, so the minimum sales, okay, so there are 12 weeks, so 12 weeks po ni siya. So the first quartile is so tulo man ni ka ano. So 12 divided by 4, so there are 4 quartiles. So the first 3 weeks is the first quartile. The second would be the second quartile or the median. Then the third and fourth quartile. Or the third quartile is the last the second to the last three, and then maximum. So it's the fourth quartile. Then you have the maximum, the mean, and the median. So these are already calculated. So we can now make our box plot. Okay. So in short, all of those visual tools can be used to present your data. So it just depends on how are you going to present your data in a visual tool that you think is the most appropriate, that can really convey what information are you going to convey to your client or to your audience. Okay, so now we're done with the visual tools, visualization, and we're done with the uh, your subject, business analytics. So I hope you have learned something, even if it's just little. So before we go, so please ask questions or clarifications. Do you have questions, clarifications? Okay, so if you have no more questions, then thank you for Thank you for attending our class. So hope to see you next week for our final discussion on financial modeling. Okay, so thank you for your time. So thank you, everybody. Okay, see you next Monday.